Good evening, ladies and gentlemen. My name is Don Morrow, Head of Dairying at CAFRE, and I'd like to welcome you to this, the first of 3 weekly webinars on calf housing and management. The CAFRE calf unit was completed a little over a year ago, and we had planned an open day here at the campus about this time of year to demonstrate the unit and outline the management of the calves with experience of 1 year's use. Unfortunately, we haven't been able to do that, so we've prepared these webinars based mainly on the unit with speakers and support from AFBI, and in later webinars the international calf nutrition expert Lena Leal and our local farm vet 𝐏𝐚𝐧𝐞𝐥. We'll be recording tonight's event, and it will be available through our website on CAFRE TV later. There are links to the website and our Facebook page at the end of this event. Tonight's webinar looks at calf buildings and the calf environment, and I'd just like to point out at this stage that one of the projects the CAFRE calf unit is involved with is the European Dairy for Future project, and one of its aims is to reduce the costs and greenhouse emissions of dairy replacement production. This is a list of our speakers for tonight and the panel to answer questions at the end. We plan that each of the 2 presentations will last about 20 minutes, and then we'll take about 20 minutes at the end for questions. In terms of asking questions, you will have an opportunity throughout the event to submit questions. Laptop users, you can submit questions using the Q&A icon down at the bottom right-hand side of your screen. For mobile users, you can access the Q&A option by the 3-dot icon which appears on your screen when you tap the mobile screen. Please submit your questions using the All Panelists option, and we will try to answer as many of these questions at the end of the event. Okay, so without any further ado, I'll move on quickly to our first speaker. Mr. Martin Mulholland is a Senior Dairying Technologist at CAFRE. Martin led the design team for the CAFRE unit, and he will describe the new unit and the principles and technologies behind its design and operation. Unfortunately tonight, Martin is unable to join us due to a family bereavement, but he has recorded his presentation, and later on the question and answer panel, Dr. Alistair Boyle, a colleague of Martin's, a CAFRE Dairying Technologist, will represent Martin, and he will be joined by Mr. Michael Graham, who is the CAFRE Farm Manager, and can probably give us a more day-to-day view on the unit. So if we move to Martin's presentation, and if you just note that if it appears a little smaller on some screens in some formats, you can enlarge that screen by clicking on the middle icon in the bottom right-hand corner of the screen, in the middle, or if you click on the screen generally, there should be a wee magnifying glass to the left-hand side of the screen, and if you click on that, that will magnify the box. So, Alistair, if I could ask you to play Martin's presentation, please.
Good evening, ladies and gentlemen. My name is Martin Mulholland, Senior Dairying Technologist, CAFRE. This evening, I would like to talk to you about the design of the new CAFRE calf house and the post-weaning heifer house. My presentation will cover the specification of the CAFRE calf house, where and why it is located in the farmyard, the ventilation and drainage within the house, the choice of environment available to the calf, cleaning and disinfection, labour efficiency measures incorporated into the design, and training of students in the new calf house. The calf house has dimensions of 35.2 metres long by 19.2 metres wide, with eaves height of 3.5 metres. The specification includes 40 individual calf pens, 2 automatic calf feeders, each servicing 3 milk feed boxes and 3 concentrate feed boxes. Each milk feed box is also equipped with calf weighing scales. There is also a straw storage bay, a milk preparation room, a store room, and an isolation area for sick calves. The calf house is located in the southwest corner of the CAFRE dairy farmyard. As you can see from the aerial image on the screen, the farm office and courtyard face due south. The predominant wind direction is from the southwest, as indicated by the red arrow. The calf house is therefore the first livestock building in the farmyard that the prevailing wind blows over. The calf house has been deliberately located in this position to minimize the potential for airborne disease-causing pathogens to be blown from older livestock buildings towards the calf house. Turning to ventilation. Ventilation in calf houses is critically important to remove disease-causing organisms from the calf house to minimize the risk of disease infection. Good ventilation also removes excess moisture, keeping the calf house dry, which also reduces the survival of disease-causing organisms. As you can see from the image on the screen, there are no side or gable walls in the calf house. Instead, there are individual pens with solid sides and top covers for individual calves for the first 7 days of age. There are 6 igloo pens, each with a straw-bedded pen in front. The individual pens provide microclimates for the youngest calves, and the igloo and straw-bedded pen give the older calf a choice of environment to be in, depending on wind speed, wind direction, and temperature. The igloos are designed according to the manufacturer, so that wind blowing over the igloo creates a negative pressure at the highest point, drawing air out of the igloo through the ventilation outlets that you can see on the top. The ratio of the size of the inlet area at the front of the igloo to the size of the ventilation outlets on top is designed to result in slow, draft-free air movement within the igloo. From having released smoke pellets in the igloo and watching the smoke movement, the effect appears to work as described. In the second presentation tonight, my colleague Aaron Brown from AFBI will discuss some of the ventilation issues found in calf houses on local dairy farms participating in the Optihouse research project. The deep straw bedding that you can see in the slide also provides calves with the opportunity to nest into the straw, creating a localized microclimate for itself. In addition, calf jackets also give the young calf additional cold tolerance protection. Calf jackets have been researched by AFBI, 𝐏𝐚𝐧𝐞𝐥 and the AHDB, evaluating whether jackets improve calf health or performance. The research in general indicates no significant impact on calf performance or health, but what the local AFBI research did show was that calf skin temperature was approximately 6 degrees higher for calves fitted with jackets, indicating that fitting calves with jackets for the first 4 to 6 weeks should help calves manage cold weather conditions. However, where calf jackets are used, provision must be made for cleaning the jackets before reuse to avoid disease spread. When it comes to the issue of temperature, many farmers will instinctively feel that the canopy roof structure of the CAFRE calf house will be too cold for calves. Before we finalised the design of the new CAFRE calf house, we purchased an igloo and a veranda, which is equivalent to the roof canopy over the single bedded pen in the new house. We recorded the temperature data for February and March 2017 using loggers positioned in 4 locations with the data from those loggers displayed in the table. The data indicates that there was little difference in the average temperature in each of the 4 locations, which is what we expected, as the young calf generates limited heat with which to warm a calf house compared to older cattle. Turning to drainage. Drainage in calf houses is very important. Poor drainage leads to damp houses with increased relative humidity. The increased humidity supports disease pathogen survival and also reduces the calves' cold tolerance. Careful consideration was given to drainage at the design stage of the new CAFRE calf house. The image on the screen shows the concrete floor area of the calf house where the individual calf pens are positioned. A 1 in 50 fall has been created from the back of the calf pen to the front, indicated by the arrows pointing from left to right and from right to left, with a further 1 in 50 fall from the centre of the calf house to the outside. Within the igloo pens, there is a 1 in 50 fall under the igloo, with a drain placed just behind the igloo to catch any dirty water runoff. There is also a 1 in 50 fall from the front of the igloo through the bedded pen area. This fall drains liquid towards a shallow slurry channel at the front of the pen, which is covered with 2 metre wide slats, raised 150 millimetre above the bedded pen floor. This gives a solid concrete curb against which the dirty bedding can be loaded when the pen is cleaned out. Holes are drilled at 500 millimetre intervals to drain the liquid to the slurry channel. The channel has a fall of 1 in 100 along the length of the calf house, and the slats have a narrow 15 millimetre gap width suitable for young calves. Past experience indicated that the dampest area of an automatic calf feeder house setup is around the milk feed boxes. For this reason, the automatic calf feed boxes are located over the slurry channel slats to keep the pen floor areas clean and dry. In terms of cleaning and disinfection, all calves are placed in individual pens for the first 7 days of age to allow the calf to be fed its dams colostrum for 4 to 5 days before it is transitioned onto milk replacer. More information will be given by my colleague Alistair Boyle in the second of our series of webinars on calf feeding. Once the calf is moved to the group igloo pen, the vacated individual pen is wheeled out of the calf house to a wash bay in the lower yard where it is thoroughly cleaned, disinfected and rested before being occupied again. You can see the wheels mounted on the individual pens in the slide. Each individual pen will be occupied by 4 to 5 calves during the calving season, which currently lasts from September to March. As mentioned previously, the calves are fitted with jackets soon after birth, with the jacket kept on the calf for 4 to 6 weeks. Before the jacket is used again, it is essential that it is cleaned. CAFRE have installed washing and drying facilities in the milk preparation room of the calf house. You can see the equipment in the picture on the slide. Feedback from CAFRE advisors based around Northern Ireland suggests that some farmers are able to make use of commercial laundrettes to have their calf jackets cleaned. Replacement heifer calves stay in the igloo pen from weeks 2 to 10. They are weaned off milk replacer in the igloo pen and ideally stay in the igloo pen for another 1 or 2 weeks post-weaning before being moved to the post-weaning cubicle house. After each igloo is emptied, the igloo is lifted out of the house using the hook you can see on top, taken to the wash bay and thoroughly washed and disinfected before being returned to the calf house. The dirty bedding is removed using a farm shovel and taken to the midden. The concrete floor under the igloo and bedded pen is then thoroughly brushed out. At this stage, the pen is not pressure washed to avoid wetting the rest of the house. Each igloo pen is generally used twice during the calf rearing season. At the end of the season, the house is completely cleaned out, disinfected and rested again before the new calving season. On farms with year-round calving systems, design provision would need to be given to creating a break period when calf housing can be thoroughly cleaned and disinfected. Additional hygiene provisions specified in the design of the calf house include automated milk replacer teat cleaning, which you can see on the slide, and an industrial washing machine for washing milk bottles. Stainless steel sinks and flexible tops have also been provided to make it as easy as possible to clean milk buckets and water bowls, etc. Hygiene and its impact on calf performance will be discussed in much more detail in the third of our series of webinars with data again from the AFBI Optihouse research project. Turning to the subject of veterinary medicine storage, vaccines are a big news story at present for obvious reasons. For the human coronavirus vaccines to be effective, they must be stored and handled correctly at specified temperatures. The same applies to cattle vaccines. CAFRE has a strict vaccination protocol to protect replacement heifer calves against pneumonia, which will be covered in our third webinar in early December. To store our vaccines correctly, we have installed a small wall-mounted medical fridge, which you can see in the image on the slide. Alongside it is a lockable medicines cabinet to ensure that we meet our quality assurance standard responsibilities. Going forward, all calf treatments will be recorded in new dairy herd management software, accessible to students and staff through smartphone apps. These electronic records will be much easier to use and to review with the college vet to assess where we can improve our disease management practices going forward. In terms of labour efficiency, calf rearing can be a time-consuming aspect of dairy herd management. This new calf house has improved labour efficiency on the calf-free dairy farm in a number of ways. Firstly, by bringing all the young calves into one location on the farm. To reduce labour inputs on the calf-free dairy farm, an automatic milk replacer feeder has been used for more than 10 years, and two automatic feeders have been installed in the new calf housing. As indicated earlier, each feeder services 3 milk feed boxes and 3 concentrate feed boxes. CAFRE have opted to use concentrate feed boxes for 2 reasons. Firstly, to have individual calf data on concentrate intake on which to base weaning decisions, and secondly, to avoid open meal troughs becoming an attraction for birds in such an open building design. The milk feed boxes are each equipped with half-body weigh scales, which automatically weigh each calf as it feeds. This data is readily available through the 𝐏𝐚𝐧𝐞𝐥 software, freely available with the automatic feeders. The accuracy of the automatic weighing has been checked a number of times by CAFRE students, and we have found a very strong correlation between the automatic and manual weighings, with over 90% of any variation between the 2 methods explained statistically speaking. We have retained the igloo and veranda we purchased in 2017 to trial the system, and we plan to use it as an overflow area for some of our beef calves. To demonstrate labour efficient calf rearing to our students, we have purchased a milk taxi which automatically mixes milk replacer and dispenses it in a controlled manner both to calves in the veranda and to calves in the individual pens being transitioned on to milk replacer. The commercial bottle washer and convenient washing facilities described earlier also add to labour efficiency, and investments of this nature on farms to make cleaning easier and quicker could make considerable improvements to hygiene practices on farms. Convenient storage of straw, as you see in the image on the screen, beside and between igloo pens, makes straw bedding easier and quicker, and also helps keep the calf house cleaner. Turning to the second of our new calf houses on the farmyard, the post-weaning heifer house. After weaning in the igloo pens, the replacement heifer calves are moved to the post-weaning heifer house that you see on the screen. Bull and beef calves will either have been sold or moved to the beef unit on the AFBI farm by this stage, depending on the numbers required for our beef production programme. We are currently increasing our use of sex semen on the dairy herd, and we monitor our breeding records closely as we go through the breeding season to try to minimise the number of Holstein bull calves born on the farm and to maximise our beef cross calf value. The post-weaning heifer shed has dimensions of 35.2 metres long by 19.2 metres wide, with eaves height of 3.5 metres. The shed contains 84 calf cubicle places, each 1.5 metres long, with division spaced at 0.9 metre centres or 5 foot by 3 in old money. The cubicle beds are covered with a continuous length of mat for comfort and insulation. The passages have solid floors and are scraped by a chain-driven scraper to a small slurry tank at the north end of the building. The scraped passage floors have a 2% slope to the centre and a 1% slope from south to north to drain liquid to the slurry tank. Prior to weaning in the calf house, the calves are introduced to good quality grass silage placed in the passage in front of the igloo pens. My colleague Alistair Boyle will discuss the weaning process in more detail and the rearing performance of heifer calves from last winter and from this season to date in the second webinar next week. An isolation pen and a concentrate feed storage area have been incorporated into the south end of the shed. All lighting is LED. An open covered bay has been constructed at the south end of the shed for demonstration purposes during open days, hopefully in future. Handling facilities are next door in the mating heifer house, where students weigh the heifers to monitor post-weaning performance. As already mentioned going through my presentation, student training is an integral part of everything we do at CAFRE. Squads of students are involved each morning and evening through the working week, and the students are trained in all aspects of calf management, from calving skills to operating the new high-tech feeding equipment, administering vaccines and keeping health records, and the more mundane but essential tasks of cleaning equipment and utensils before and after use. Ladies and gentlemen, that concludes my presentation. Thank you for your attention. I will now hand you back to our chairman, and I will be happy to take questions during the question and answer session after the second presentation in this webinar. Thank you.
Thank you for that. As I said, Martin can't be with us this evening, so it'll be actually Alistair that'll be taking the questions at the end. But you can ask questions again at any time. There's a few have come in using the little Q&A button at the bottom right-hand side. I believe as we were showing their presentation that there were 2 or 3 folk who couldn't actually see the presentation, and as far as we can tell, that seems to have been a broadband issue with them at the at their end with iPhones particularly. If you have had connection problems, maybe if you just let us know, it'll give us a bit of feedback for future presentations. Now, Moving on to our next speaker. Our next speaker is Aaron Brown. Aaron is a PhD student based at AFBI Hillsborough, and he's involved in the Optihouse project. Optihouse is a large-scale calf housing project which is currently being carried out on dairy farms across Northern Ireland by the Dairy Youngstock Research Team at AFBI. And the initial work in collecting some data was in collaboration with the CAFRE Dairy Advisors. The project itself aims to provide a better understanding of calf rearing units and houses within Northern Ireland and the key factors linked to the suboptimal environmental conditions within these rearing accommodations, as these can have a significant impact on calf health and performance. Aaron's presentation tonight is on his initial findings from the study of calf housing on local commercial dairy farms, and on the panel later, Aaron will be joined by Dr. Gillian Scoley, a calf research scientist at AFBI. So, Aaron, if I could ask you to make your presentation. Thank you.
Thank you very much, Don. So I'm Aaron Brown, I'm a PhD student at AFBI Hillsborough, and looking at the environment and housing of the pre-weaned calf. So this evening I just want to quickly look at three sort of areas. Number one, sort of targets for housing and housing design. Secondly, sort of what we are seeing on farm in the Optihouse project. We're on 66 farms. And then finally, and very briefly, sort of some of the changes that were made as part of the intervention study and sort of quick finds from that as well. Okay. So why focus on calf housing and the environment? So the rearing environment in itself can have a negative influence on the calf, and there's two ways that can happen. Number one, by creating a sort of a high or a large pathogen challenge. So that's basically poor hygiene. So poor hygiene will present a greater risk of disease to the calf, whether that be calf scour in the sort of the first month of life or respiratory disease thereafter. Certainly, pre-weaning mortality across the UK would be about 6%, and that's from a study done with Bobby Hyde over there in Nottingham, and it's similar over here. And that hasn't really changed over the past few years, and despite the changes that have been made, and so that's been fairly consistent. Not only have we to worry about the sort of the level of bugs that the calf is in front of, and is they're within the calf environment, but also the rear environment and the housing can have an influence on the physiological stress the calf is placed under. And what I mean by that is calves where the energy the calf is consuming is being used in other areas that aren't performance and immune function. So the calf is having to compensate for low temperatures or draft or dampness. And I'm doing that by the likes of vasoconstriction and sort of hair stand on end, shivering, all those sort of things that are wasting energy. And certainly that will reduce feed efficiency and immune function. And in terms of a pre-weaned calf, we want to maximise that, and we want to maximise the performance within this period, sort of in terms of the metabolic performance later in life with the organ development. But we also want to manage the cost of rearing, so we don't want to be feeding the calf for it to be having to spend it all on the environment that it's in. Certainly within the Optihouse data set, calves, there was approximately 400 calves we looked at, or more, but 400 in the pre-weaning period, were growing about 140 grams less per day than their diets were predicting. And so there certainly is, and that there takes into account the temperature, so there certainly is a bit of loss happening. And that's where I'm at currently in terms of analysis, looking at sort of the different environmental aspects that might be predominant in that. But ultimately, why focus on calf housing? So like, if our calves can thrive in this environment, the calves can thrive during the pre-wean period, so we can maximise in lifetime performance. We're building our cow at this stage, and it's important that we do it right. So what environment does the calf want? So I've sort of broken it down in a couple of areas. First of all, a clean environment. So it's a neonatal calf, and as such, we need to ensure that the environment that it's reared in is clean. And the routine hygiene is to talk for another day, as Martin said. Additional to that, we want an adequate space allowance for the calf, and that's basically an equation of less area per calf is going to be an increased bacterial contamination per metre squared. So the bigger area we give it, the less dense the bacterial contamination is going to be. Added to that, we've got the ventilation, and it wants a ventilated airspace. Ventilation, it being warm and dry are all very much linked, and Martin touched on this earlier. We want an airspeed between 0.15 to 0.3 meters per second. Any more than 0.2 meters per second, we're talking about a draft, and that there in itself is going to physiologically stress the calf. Also, we want a relative humidity less than 80%, as when it gets above 80%, the survival rates of bacteria in there are much longer, as they can, as the size of the molecules that have been held in the air are able to be larger. And added to sort of the warmth, obviously we want an environment that's over 15 degrees Celsius. That doesn't happen here, as you'll see shortly, for a large period of time. And that's when our calf, below which our lower critical temperature of 15, below which the calf is going to be spending energy and all those other different ways that I talked about. And again, draft free. We want the environment to be draft free, so that the calf should be able to, whatever type of housing it is, the calf should always have the option or somewhere that there isn't a draft on it. And that will reduce the effective temperature through wind chill. And then it being dry. Obviously, bedding's a key part of that. The cows are lying down for 70 to 80% of the time, particularly within that first month. And we want that bedding to be dry, not only to insulate the calf, but if the bedding's damp, then you suddenly take that from being an insulator to being conductive and sort of taking energy from the calf and further stressing it. As well as that, adequate drainage, which is a very important part of this. Calves are putting out so much moisture, ensuring that moisture has been taken away, not only as in terms of being a contaminant, but also to maintain the dry floor, the dry bed. And finally, just obviously a stress-free environment, not only through sort of the routine procedures that are happening, making sure they're stress-free, but also ensuring that there's a level of social contact. And certainly as the calf gets older and we're trying to get the calf to eat more starter coming up to weaning, there's certainly studies that would show that it is beneficial for this stage for calves to be grouped and to at sort of a lower stress in that time. So in terms of the Optihouse survey, a very, very quick summary. 66 dairy farms were visited over a period of 3.5 months. We started in 2019, and this is done in partnership with the CAFRE Dairy Advisory Team. And there's a very brief or a very there's a summary there of sort of where the geological distribution of the farms across Northern Ireland there. This survey took into account a lot of things like housing, but more than that, sort of the diets and everything really that was involved. So first we'll have a look at the thermal environment. So I'll break this down. I've divided these sort of the readings up by sort of the type of calf house. Number one there, the hutch. So obviously your manufactured hutch, and there are various makes of those. And then the open-sided housing, where you've got a house that's completely with one side open, and then the direction of the open side varied, and I'll touch a bit about the direction later. And then a closed housing where you would have basically all walls are somewhat restricted, not necessarily completely sealed, but at least with cladding on them. And as you'll see there, the majority of the houses were that type, and there were very few hutches and open-sided houses in relation to that. In terms of the percentage of time that the farms where the temperature within the calf house was less than 15 degrees, 92% on average, so the majority of the time below 15 degrees, and that didn't really change much, or there wasn't much sort of variation between the different housing types, whether that be hutch or open-sided or closed housing type. So certainly there wasn't much change or difference there. Looking at the inside versus sort of the outside temperature, again, very little difference. But on average, you're sort of looking at 1 temperature degree warmer inside the house than outside. So there isn't much sort of that would be different between those. And then looking at the relative humidity again, you're sort of the percentage of time that the relative humidity is above 80%. Again, it's all sort of in that there between sort of 60 to 70%, and average of about 64. Finally, there, just looking at the average percentage time spent above 0.04 meters per second, and the reason I picked that reading is the particular loggers we're trying to use And really the only type of log that you would be able to log in this case is the wind vane anemometer, and it can't really pick up the wind speeds below that 0.04, as it obviously won't turn the vane. But what we can see there is the percentage time that the wind was strong enough to turn it, and that's sort of above 0.04, which in the case of a calf pen would be a draft. And one thing I would sort of note there is that there was, I can't say for a particular number of the farms that had open sides. And again, I say there was a varied direction, so some of these open sides might have been facing the prevailing wind, and certainly that's something I'll be taking into account when designing a naturally ventilated house, is sort of avoiding that. But it's something to be aware of, ensuring that calves can get out of the draft, can get in behind something, and that they're protected from that. In terms of ventilations, obviously, there's two main sort of purposes in terms of ventilation. Number one, we want to bring in fresh air and clean air and remove the sort of contaminated air. Number two, we want to remove moisture, and we want to create as dry an environment as possible. And that's certainly a target for me in terms of calf housing, as a dry floor and just maintaining a dry environment where pathogens struggle to survive as long. And we obviously want to target fresh air for all calves at all times, and I'll talk briefly about sort of naturally ventilated houses and where the limitations there are. 90% of the calf houses within this study are naturally ventilated. Very few of them were running with tubes, and some of them that had the tubes in weren't even running them. An average volume per calf was 21.6 meters cubed, so in general quite high. And I suppose there is benefits in that if you're keeping animals for maybe up to 4 or 5 months of age in that house, that could be very useful. But if they're only pre-weaned calves, then I would say that it's fairly generous. Certainly as a minimum, you're looking at 6 meters cubed per calf, less than about 100 kilos. But quickly now looking at there's the two different types of housing. If you're naturally ventilated on the right, which sort of using that's a space boarded house, or you could have Yorkshire or double cladded, and then on the left you're looking at a positive pressure tube, which would deliver air at all times. In terms of naturally ventilated houses, there will be targets that we could use to maximise the sort of efficiency of them. Now, as I've written there, in an ideal world, and the reason being, obviously, there are certain scenarios where we cannot meet all these, and there are farms that are built in certain areas. And I know there's farmyard planning, there's a lot of other things that have to go into it. But in terms of you're thinking of designing a house, the things that I'd be thinking of trying to avoid or trying to design, and certainly first one will be the situation of the house, and Martin mentioned that earlier. The prevailing wind side of other livestock buildings, and not only because we want to minimise contamination from other livestock, but we also, to give it the sort of, that you're not having other barriers blocking the run of wind to that house, and there isn't wind channels and things affecting that. Not only that, but the orientation of the house. So I would ideally have the house, the longitudinal side, so the long side, facing the prevailing wind direction. If you have a mono pitch, putting the back of that to the southwest, and ensuring that we get as much that is equal across the house as possible. And we're not blowing air up through the house across the ends of calves. And then the topography, which I would think is probably the most important one for me, is where we're building at. If we're going to naturally ventilate a house, avoiding hollows, and sort of some of the research goes back into the time, even as far as foot and mouth, when they were seeing that the foot and mouth virus was particularly prevalent in animals in houses that were built in hollows. The virus itself seemed to be moving in air plumes along valleys, and certainly if you think about it, like thinking about your fog, your mist that's lying in the low-lying areas, trying to have houses built on exposed sites where we can get as much from wind as possible, and then ensuring that we have consistent inlet cladding across all pens, rather than having a large gap over a door where we have a large amount of uncontrollable wind coming through, and that's creating drafts. Ensuring likes of your Yorkshire board and your space board and whatever, that's breaking that down and distributing that across the house. And looking at a target ridge area, so that's if you have an apex ridge. And in terms of calves, you're looking at approximately 0.04 meters squared per calf. If you're obviously a monopitch, that isn't an issue. And then finally, and I put this in because it's a key problem with naturally ventilated houses, we would like it to be windy all the time. Now, if it's obviously not windy all the time, we have issues because there's not going to be wind-driven ventilation. And with calves being all the size of they are, and their body weight to body surface area ratio, and the fact they're not fully functioning ruminants, all these different things, the calves in themselves don't put up quite enough heat to generate the stack effect in the same way, and ventilation itself won't be as effective. And there's where I would be advocating the use of a mechanical ventilation, the likes of a positive pressure tube to ventilate those calves at all times. And there's certainly no reason why that a properly designed tube should be able to deliver that without delivering draft. So looking then quickly at the sort of how we're calculating the ventilation requirement of those buildings. So we obviously measured up the outlet area of the building. So outlet, we want obviously talking about that 0.04 meters squared per calf, and in terms of inlet, we would like that on each side of the house. So on total double that. And this is sort of the way we're sort of calculating the requirements of that building based on the animals. So we're using the AFBI sort of methods for that in cooperation with Jimmy Robertson of LMS and sort of the techniques that were built up from the SRUC previously. And this takes into account the building area, the roof pitch, so the steeper the pitch, the more effective, the stock and density, and the live weight of the animals in the house. So in terms of what we're seeing, look at table 2, basically, if you go straight to the bottom row, 0% of the required outlet area, and then 41% of the calf houses, so 41% of the calf houses had 0% of the required outlet area they needed. So what that basically means is that those houses had no outlet whatsoever, and that in terms of ventilation is not going to be a work at all, because your air's coming in, it's got nowhere to go, and if you have certainly if you have no wind or any gas, you have an air that's collecting, and that's when you're going to have issues with pneumonia. On the other side of the spectrum, you've got 15% of the calf houses that had over 200% of their requirements. So basically, the outlet is double the size, or double or more of the size that it needs to be. And that particularly as a trend I would see with newer calf houses that are going up more recently, is the sort of trend to overcompensate for outlet area, and in a way that in itself can become a hindrance. If it's too large, you'll end up having a ridge whereby your wind's going over the house, and rather than pulling air out of the house, it's blowing in and disrupting the whole thing entirely. And there's also a justification for or a need for the right sort of design that's creating that pull rather than facilitating wind coming through the side. Okay. Looking then at the stocking density, so Ken Nordland, who's based over in the US, where a lot of the ventilation work would come over, certainly with mechanical systems and all that and the likes of that. Would recommend in about 3.3 meters squared per calf, and that's based on a study that looked at the sort of air, the bacterial air counts within calf houses, and the justification of that 3.3 is that as you reduce the space allowance per calf, you'll increase the air counts within that, and therefore predispose yourself to lower air quality and pneumonia risk. And certainly you'll see there a variety of the different types of calf pens and the stocking densities within them. An average across all the types of pens would be 2.3 meters squared per calf. And then if you're looking there at the average group, the minimum there is at 1.34, that would be a bit low. So we'll be trying to average in around that, as close to that sort of 3 meters per calf, squared per calf, if you're going to keep the calf all the way till weaning. And then you'll see there the hutch system, you're sort of at an advantage there already, because a lot of those hutch designs are allowing for that, and they're the hutch and the pen out the front, or whatever way it's designed, they're generally given that sort of 3.1. And even there with the minimum there, 2.2, that's a hutch on itself without the pen. So there is advantages in them systems that you're ready there with the space allowance. In terms of the other advantages seen with increasing space allowance, studies have seen that you have increased dry matter intake of starter later on. So particularly with older calves, I can see benefits and reduced laying times. Looking then at drainage, so obviously a variety of floor types within the calf houses. Obviously the majority with a concrete floor, a solid concrete floor, which we would really need a slope on. And then 33% of the farms with the concrete run onto slats, and 9% with a sort of permeable surface, whether that be gravel, under straw, or wood chip. So obviously a slope on a solid floor is very much essential to manage moisture. Otherwise you're collecting it. And I would sort of use the figures 1 and 20 slope designed to allow for that. 92% of the floors that were measured were less than that, sort of 5% 1 and 20 slope, and that's obviously a major risk in terms of getting the moisture away. Certainly, trying to remove the moisture the calf's producing to maintain a dry floor, not only from the point of reducing the moisture in the air, but also in terms of sort of your disease management. And sort of there's sort of some situations that I wouldn't like to see. Not only have you the issue of increasing the humidity in the house, but in terms of disease management, how do you control pathogens and that if you're walking through that every day, whether that be in the first two pictures within on the passage where you're working, or whether it's in the calf pen itself in the right picture. We obviously want to minimise that, and as I say, I would be targeting a dry floor, dry surfaces as a good indication of a cleaner environment for calves to be reared in. In terms of lighting's not something that's often touched on, and to be fair, it's fairly simple. In terms of the benefits of calves, as lighting's increased, previous studies, and there hasn't been any studies done on light, as you increase from 20 lux to 130 lux, there was an increase in these calves of feeding behaviour, and that's increasing in terms of starter intake. And again, as we want to start weaning our calves off, we're very conscious that we want them to be eating start at this stage and increase in social behaviour. Then in the lower light intensities, there was increased laying behaviour. And other studies that have looked at increasing the light period and things like that have also seen the same trends towards increased dry matter intake and increased and reduced laying times. So sort of a general target, I'll be targeting at least a minimum of 100 lux. I know the AHDB for older heifers will be looking at 170 to 200 lux, sort of for that general, as you're coming towards sort of puberty. 23% of the calf houses had no natural lighting on the roof, and that doesn't take into account the sides, but in general, natural light, the fact that it's free, I would be trying to take advantage of that. And get as much, and to sort of create that environment that calves are wanting to get up to date, especially as they come up to weaning. In terms of what we're seeing on farm here, so there's averages here with it when the lights are turned off across several pens, and when the lights are turned on and turned off, and the lights turned on would exclude touches, so you'll notice a discrepancy there with the averages on and off. So on average, you're talking sitting near 600 lux and the lights are on, but down at a minimum of 8 lux, which really isn't a very functional lighting system for any calf house. And I would be sort of urging to it's not the most difficult things in the world. It's very straightforward, but it does have an impact. And 20% of the farms when the lights are turned on were below that lux target. So there is room for improvement there. If that's your calf house or whatever, there is something to take into account. Just mentioned there a particular type of you'll see there the max, the lights off is 12,447. That's particular sort of a transparent, an older design of a hutch that's more transparent, and certainly some of the newer designs will be a bit more opaque than that, and will be more insulative as well with that. So briefly, just looking at the intervention study. So obviously we're making changes and in the housing, but also in routine management in particular areas with 19 farms. And I'm just going to briefly mention these two here. So these changes were made to improve the hygiene and the calf performance and health. This was a bit of an effect of the coronavirus lockdown on the study. But I think we're able to see a few things here, particularly with this farm who inserted the positive pressure tube and removed what the idea is sort of out behind the back there, the back of the shed. You'll see what looks like a sort of a hoverboard design to keep cows warm, which I believe is sort of acting more as a bacteria fest really. And then also the drain was put in on the left hand side of the passage up on in front of those left hand pens. Now, so that there, the idea was to improve moisture control, to improve the quality of the air, and certainly this farm had a previous issue with pneumonia, and there was a lot of, and I think from the season before where they were losing, I think they lost 5 calves with pneumonia, having lost none this year, and then and certainly with very few very little medicine usage over that winter period. There's no change in the diet in that time, so there hasn't been much apparent difference in the growth rate of calves, and that's the same with this farm here I mentioned now. This is quite a large change, as you can imagine. There's a whole wall missing there. Again, this guy is having more of an issue with scour, and certainly during the months of January and February, he's having issues with 50% of the calves as he got to the end of his calving season. So not only there has he took that wall out, he's raised the height of the wall at the back to allow him natural ventilation. He's on a particularly exposed site on the east coast, and that allows sort of a fairly consistent flow of wind coming up the hill at him. And not only that, he's added the drainage there in the floor, and he's changed his pen design, and he's actually gone something I'm particularly fond of is painting the wall white. Not only making something easier to clean, but also improving the light in the house. And again, he's gone from having a lot of issues with scourge in that time to having very few, and having, I think, within the single figures in terms of treatments. And then I think he only lost 1 calf that last season, as opposed to about 1 or 2 calves per month, which was the previous situation. So finally, just sort of some take-home messages. In terms of, I mentioned at the start of it, the temperature. Certainly, non-housing management is required to deal with the lower critical temperatures. And that being the fact because there isn't much difference between the inside and outside temperatures of calf housing. Certainly, we need to minimise drafting and minimise dampness. But we do need to feed our calves appropriately. We do, and there's certainly benefits in the use of jackets and heat lamps and ensuring the bedding is always dry. Over 50% of the houses surveyed would would fail to deliver competent ventilation, so that's the ventilation isn't going to be effective. The majority of the slopes, of us 94%, were less than adequate to drain pens, and certainly those two things in themselves, making improvements in both these areas, will help not only moisture control, but also helping to create that cleaner rearing environment for the calf. And then finally, as a target for myself, is to always be targeting dry services in the calf house. As a very visual thing for you as you're in and out of the calf house every day is seeing, like, in terms of the floor that you're walking on, and the floor that the calves are on, and other surfaces as well. Thank you very much. I'll leave it back over to Dawn.
Aaron, thank you very much. And you went through an awful lot there in a relatively short time. I appreciate, folks, we're approaching 9, and I talked about finishing at 9, but I think we'll try and get around at least 1 or 2 questions to each of the panelists quickly here as we go along. And thank you to those that have sent in questions. And if there are any last-minute ones, we'll try and get them fitted in. Most of them following a theme, and I might start with Michael, because you've had it easy so far, Michael. So I'll ask you to unmute, and then I'll ask you just probably the main feature of the CAFRE house is the fact that it's got that open plan, open sides. Do you think that that open plan calf house is suitable for most dairy farms in Northern Ireland?
I think Donna has worked very well in our situation, and there shouldn't be any reason, provided it's cited properly. That has been highlighted by both the presentations this evening, and if it's cited, or plenty of clean air coming up to ventilate it. The other important consideration would be the choice of the igloos. The igloos that are chosen for the Greenmount house ideally hold 12 to 14 calves up to weaning. And with the calving pattern numbers of cows calving, we can fill one of those igloos relatively quickly. And it means that those calves are of the one age coming through and then weaning at around the same time. And that helps obviously in, not only in calf performance, but getting them weaned and able to take the group away to the follow-on house and then cleaning and resting the building has been successful. So someone maybe with a wider calving, more scattered calving pattern may need to look at the igloo they choose, the number of calves that they can put into it, fill it relatively quickly to keep the calves of similar age and bring them through to weaning at a similar age and group size.
Thank you, Michael. And I mean, it's sort of a theme here coming through in some of these questions. And the other one, and I'll address it to Alistair, if you don't mind, just in Martin's place. There's a bit of fervent interest about the calf jackets. And do you think the calf jackets are a must for calves born over the winter months in our position and in other calf units?
Yep, thank you for the question, Don, and I think Aaron has alluded to it in his presentation as well. I would say yes, particularly if the calf is less than 3 weeks old. It is very important. A newborn calf will feel the cold when the temperature is between 10 to 15 degrees. So in winter, it is going to be lower than these particular temperatures. And if the calf is putting additional energy into keeping warm, this is going to impact on daily live weight gains and growth performance. So, say within the CAFRE calf unit, the jackets are fitted to calves for a 4 to 6 week period. So I would say yes, they definitely do have a place, particularly in light of Aaron in terms of his presentation and the temperatures within the calf houses.
Very good. Alistair, thank you very much, and I'll just keep moving on. Aaron, I have two questions for you. One is a very quick one on as a clarification on your presentation. In the diagram you had on the vent in the calf house, the air vent, there was a wee baffle at 5 degrees. Is that 5 degrees crucial?
But the baffle is in where the hole is on the.
Yes. Yeah.
Well, as I say, it's designing the tube for your house is very important. Now, it's not going to be 5 degrees for every calf, it's for every house. And that's why I would stress if you're putting in a ventilation tube that it's designed for the house. And there are companies that will come out and do the measuring up on the designing for it. It's because the design will ensure that designing the tube will ensure that the airspeed hitting the calves at calf height is not too high and it's not drafting the calves. And as I say, it's very much the design. It's not always going to be 5 degrees. It changes. It changes in the design. Certainly, if the ones I've seen put in, there's variation in the degree of angle.
Thanks, Aaron. The other question is just, and it's a more general one, but what's the best type of, and this is you just keep this as specific as short as you can because we've got to. What's the best calf house you have seen on farm to date, and what features made it the best?
There's a lot of good calf houses out there. I would say there was two particular calf houses that stand out to me, and they're not exactly the same at all. They're very much as about where they're put and how they're put there, and a lot of other things. One is a monopitch, the other is an apex roof. They're both situated on a west southwest facing side of the yard. They're completely their longitudinal sides is in the right way. They're on the side of it, not in a hollow. They're on a bit of a rise. But a lot of other things have been right in terms of the stocking densities. Both are coming close to about 3 meters per square per calf. The slopes are right. There's the ventilation equally distributed across the house. But not only that, I suppose you're biased towards calves that you see. Obviously, a good calf house is one that produces good calves. And there's two other major things. Nutrition of those calves is going to be a big player. So comparing a farm that's feeding 1,200 versus 600 grams a day, for example, and within the first month, there's going to be a big difference in those calves. And in terms of hygiene also, I think there was a statement by, I think it was Roger Blowy, I'm not sure. It was along the lines of good housing will not correct poor management, but poor housing will worsen the effects of poor management. And that's certainly true. You can have a very good house, and if it's not cleaned properly, it's going to cause as many issues as the next one. But yeah.
Oh, well, that was a sort of a half-hour question, not 1 hour to really go through. But thank you for covering that one. Gillian, if I could come to you just with a question, and it's actually come in from here. Does calf behaviour tell us much about the comfort of their environment? Can you see it in the calves' behaviour, the environment they're in?
Yeah, well, normally calves of this age lie down for about 70 to 80% of their day, so that's about 18 hours. And it's really important that they get that rest so that they can grow. If they're lying on a cold bed, or they can't nest within the straw and get cozy, they're not going to lie down as much. They're going to expend more energy trying to keep warm. They're not going to use their feed as efficiently. They're going to send it towards growth send it towards keeping themselves warm instead of to growth and to health. So it is really important to keep an eye on calf behaviour. If they aren't nesting nicely in the straw, if they haven't got their legs tucked in their legs, and you shouldn't really be able to see their legs when they are nested. If you do have automatic feeders and they're visiting those feeders very frequently, you might have a look at the temperature. If it has dropped, you might consider upping the feed a bit. So calf behaviour is a very important aspect of the whole all-round calf rearing process, but sometimes it's a bit overlooked.
Yeah. So even when you have the automatic feeders in there, you'll still see that behaviour if you keep an eye on the things.
Yeah, automatic feeder. I mean, nothing's ever going to beat the eye of a fat person, but these kind of automatic feeders and everything, they do give us a lot of information, such as drinking speed. Because dropping that can be indicative of ill health. Lots of unrewarded visits can be a sign that they haven't been filled with by their feed. So using those bits of technology can be really helpful to try and get an all-round feeling for what's going on at calf level.
Okay, and thank you. Alistair, just I'll take a question with you then on a similar theme. Someone here has asked, has CAFRE noticed any issue in terms of the calves sharing the same automatic feeder? In other words, has there been any sign of a spread of pathogens or disease through the automatic feeders?
And maybe Michael can come in here as well, but we haven't observed any major issues with scar in relation to sharing of the same teat. On one of the machines does have an automatic teat washer, and I believe we are planning on putting automatic teat washers on the other machines. But in terms of scar, issues with that, no. But obviously we have different protocols feeding into in relation to the health of the calf and in relation to our colostrum feeding protocol and feeding our transition milk. But I can't say we have observed any major issues. Michael, maybe would you like to come on?
No, I would agree, Alistair, totally. You said we've added the automatic washer to one of the units, and we will fit the other one with it. But we haven't seen that as a problem really, or have there been no spread of any issues throughout the calf house.
Michael, thanks for that. And just when you're on, Michael, there's a very quick question here. Does the rain not blow in and wet the straw? Is the question.
That's a very good question, Don, and something we were worried about when we first went to view some of these houses. And we've actually found the opposite. The straw usage is probably reduced from the conventional house we moved from, because the rain doesn't blow in as a result of having a short canopy over each side. And the draft and the nice area environment actually has kept the straw drier than the previous conventional house we worked in, and we've actually used less straw as a result of that.
Okay, thank you, Michael. I'll keep moving on quickly here because there's quite a number coming in. There is one here about the benefits of the feeder in terms of in terms of calf performance, but I'll apologise at this stage. We'll skip over that because we'll cover that in much more detail, I think, in the next webinar. I know Alistair's going to address it there. One of the other questions then is, if your current natural light was poor or non-existent, would you advise leaving lighting on during the day? Would this help? And I'll address that one to Aaron, if you don't mind, please. So that was, if your current natural light is poor or non-existent, would it help to have the lights on in the daytime?
Yeah, absolutely. That's the short answer to that. I suppose increasing light, as I say, it's certainly a benefit to calf behaviour and calf intakes. And if you can't quickly fix the natural lighting issue, I certainly would be, for the time being, working with that, but I would be trying to make the improvements that mean that you're not constantly having to leave lights on by improving the natural lighting.
Yeah, okay. In terms of, just one more here, maybe Michael, a more practical one for you. If the question here was, if 1 in 20 is the recommended slope, why did CAFRE go for 1 in 50? I think that'll be taking something from a combination of our presentations there. And is it working, more or less?
Thank you, Don. Yeah, we looked at the existing calf houses we had prior to this and looked at some of the designs of the igloo houses we visited, and we settled on 1 in 50. That has worked extremely well. On the individual calf pens where they are for the first 7 days, it's a very short distance that the moisture moves to get into a drain. That has helped. And underneath the large bedded pens and underneath the large igloo, I think that ample use of plenty of dry bedding has meant that there's been no issues with moisture at all.
Yeah, but as you say, it was a short run in one case, and the other we have sort of a natural drying surface in that case. No, that's great. There's just a few others here. And just in general, what would you say about your experiences of calf rearing facilities on the farms you've looked at? Would you say we're in a good place, or is it a very mixed picture?
I would say it's fairly mixed. I know sort of over the past while there's been a lot of emphasis on expansion in other areas of the farm, and sort of now in the last couple of years, there's obviously a lot of interest and a lot of hype, I suppose, with calf housing and making those changes. One thing I see quite a lot is the size of the housing is maybe tight on the number of calves that are actually coming. And that, I suppose, having a big impact in terms of you trying to manage, not only trying to manage the hygiene, so getting in ahead of calves to clean, to have pens clean, to have the feeding equipment clean, whatever, but also for the sort of space allowances for the number of animals in a house, for sort of air volume per calf, all those different things, is that you're actually overstocking houses a wee bit. And I think that's just maybe there's different reasons for that, but certainly I think there could be improvements in terms of scaling the size of the facilities for the number of calves. But as I say, a lot of changes are being made at the minute. People are making, I know you see a lot of changes in terms of cladding and things like that, getting away from solid tin sides and putting in the likes of cladding or of Yorkshire boarding or space boarding or whatever to try and improve airflow into the house, and that's certainly in a positive direction.
Thank you. And that, I think, concludes the majority of the questions. And I know I'd said we finish at 9:10, and I appreciate that for folk that it's been a long sit this hour. Just can I just thank you all, panel, first of all, for your answers and your contributions, particularly our two speakers, Martin and Aaron. I'd also like to thank the technical team who've kept the thing moving so smoothly throughout tonight, and especially for the help we've been able to give some folk had a wee bit of difficulty to start. And again, thank you to you, the audience, for joining. The next webinar in this series will be next Thursday at 8, and our topic will be calf nutrition, and will be particularly focused on implementing accelerated growth. And the two main speakers will be Dr. Liam O'Neill from Trow and our own Dr. Alistair Boyle from CAFRE. As I mentioned, this event has been recorded and should be available on CAFRE TV later. To access that, you go through our website, www.cafre.ac.uk. And at the end of this event, when you leave the meeting, you will be automatically given a small survey, a short survey. We would really appreciate it if you could answer the few questions that are there. And if you have any comments about tonight, there's a free text box at the end. Please feel free to put any comments or any suggestions or anything you feel would be worthwhile to incorporate in future events. And so that then concludes tonight, and thank you very much for your time and attention. Okay, thank you.